This is the solutions for the exam. Um, First we do number one, where we are going to take these three values of x, y, and z, and we're going to put them in this equation and calculate the value of p. Okay, so let's go a little bit farther down. So, where's my mouse? Okay. Okay, so P is going to be equal to X, which is 1.775 minus square root of, whoops, oh my gosh. Okay. This is not my regular mouse. The power went out, so I'm doing this with a different system. Okay, oops. So let's put, instead of square root of y over z, we're going to put 1.44, and instead of z, we're going to put 48. Okay. Okay, so we're going to put that in the calculator. To do that, we go over here and we first do 1.775 minus, and then if we want to put this all in one equation, we have to be very careful with the parentheses. Square root of 1.4, oops, 1.44, and then divided by 48, and then the other parentheses. Okay, enter. That gives us the answer, 1.75, 1.75. Okay, and that's the answer to part A. Then, very first writes x, y, and z to one significant figure, then uses these values to estimate the value of p. Okay, well, x is normally 1.775. Let's translate that into one significant figure. Well, one significant figure would be the first figure. It would be a 1. Now, does it stay a 1 or does it go up to 2? Well, let's look at the next number, 7. 7 would round it up to 2, so x would just equal to 2. Should we write 2.0? No, we're not going to write 2.0 because we want one significant figure. If we put 2.0, that would be two significant figures, so we just put 2. Okay? What about y? Y is normally 1.44. Now let's write 1.44 as one significant figure. Well, the one significant figure would be 1. Do we keep a 1 or do we round it to 2? Well, 4 is less than 5, so we keep a 1. So y is just equal to 1. Last of all, we have z. Z is originally 48. One significant figure would be the 4. Are we going to keep 4? We're going to round it up to 5. Well, we round it up to 5 because 8 rounds it up to a 5. But 48 is not approximately 5, it's approximately 50, so we do need to put a placeholder 50 there. Okay? Alright, now that is the answer to B1. Now what about B2? We're going to use these same numbers and we're going to do the same calculation. Okay? So let's go back over here. Keep doing that every time. Okay. And then we're going to do P, this is P like estimated. Instead of 1.775, we're going to put 2. And then we do minus square root of 1 divided by 50. So that's equal to 2 minus 0.02, which is equal to 1.98. Okay, so how does that look when you do it on the calculator? 2 minus Be careful with the parentheses. Second, square root 1, and of course the square root of 1 is just 1, so that did nothing. Divided by 50. Close parentheses. 1.98. Okay, so Barry's estimate of the value of P was 1.98. That was B2. Now let's go to part C. Calculate the percentage error in Barry's estimate of the value of P. Okay, so now we have an exact value and we have an approximate value. This is the exact value, and this is the approximate value. Okay, so to find the error, we take the absolute value of the difference of two things. One is the approximate value, and one is the exact value. Now, a lot of people got wrong what they put on the denominator. Now, do we put the exact value or the approximate value? Well, the thing is, you need to always use the exact value if possible, because otherwise it's like the denominator is going to vary along with the approximate value, and that's not what you want. If you want to compare the error between two different measurements, you don't want the denominator to be different for both. You always want to compare against the correct length or quantity. So the top is, it doesn't matter which order you put it because it's absolute value, but you're taking the absolute value of the difference of those two, and then you divide by the exact value, which would be 1.75, right? Because the exact value is this one. All right. So if you do this subtraction and division, let's see, be careful that you put in parentheses 1.98 minus 1.75 divided by 1.75, not divided by 1.98. And that gives you 0.131. Okay, so let me push this. Okay. And so let's see where, okay. So that would be 0.13143, for example. Okay, but we need to change this to percentage. To change this to percentage, we write 0.13143 times 100. What does 100 do? It moves the decimal point 2. So this is equal to 13.1. In IB Math Studies, you always want to keep 3 significant figures if you have many significant figures that you want to reduce to, a handful so that you can write it easily. You need to keep 3. Okay, then you need to add percent because 0.131 is 13.1%. Okay, so now we have this first answer is the answer for A, 1.75. These 3 answers are an answer for B, and then 13.1% is the answer for C. And and I also forgot this. This is the answer for something, right? This is Barry's estimate. Okay, so this is A, this is B1, and this is B2, and this is C. Okay, now let's move on to the second problem. So we got these 3 scientific notation numbers, and they want us to calculate the product here. So remember how to input these. We're going to do x times y to get w. So x is 2.6, and then we do EE, and when you type it out, it just comes out to be E4, okay, times 5.0, just put 5, oops, 5.0 times 10 to the minus 8, so we second EE minus 8. And if this is the first time you're seeing this, that means that you didn't do a lot of the problems, and that's why it was so hard. Okay, and so the answer is 0.0013. So W So W, oops, let's click this again. Oh my gosh, what a pain. Can't wait till the electricity comes back on. 0.0013. But they tell us to put it in this form, a times 10 to the k, where a is between 1 and 10, and k is an element of the integers. At least you guys recognize that that meant scientific notation, but a lot of you guys got this wrong. You know the calculator does this for you. Well, if you would have done all the problems, you would have known that. You go mode, scientific, and quit. Now, let's go back and grab this and say, what is that in scientific notation? It's 1.3 times 10 to the minus 3, of course. The calculator does it. The calculator can help you a lot in this class, in case you didn't notice. Okay, so now that's the right answer to A. What about B? Now we just need to look at X, we need to look at Y, we need to look at W, and then based on X, Y, and W, we're going to see which of these things are satisfied. So is X an element of the natural numbers? 2.6 times 10 to the fourth. 2.6 times 10 to the fourth is actually, a pretty big number, right? It's 26000, is that right? Because it's 2.6, and then you have to move the decimal point 4 positions. It's 26,000 actually. Is 26,000 a natural number? Yes, it's a positive whole number, so yes it is. What about is y? Is y an element of the integers, because z is integers? Well, let's see. Y is like a tiny number. It's 5 times 10 to the minus 8, so that would be equal to 0.00000005. You can think of it as, okay, you have 5 times 10 to the 8th, you have 5, and then you're going to move the decimal point -8, 2, 3, 4, 5, 6, 7, 8. You're going to make it very small. So is 0.00000005 an integer? Of course not. Integers are whole numbers, positive or negative. Okay, y is an element of the rational number set. Well, let's see. The only thing that aren't rational numbers are like square roots of non-perfect squares and what else? Pi or e. So is y is a very small number, but it's not an irrational number. So yes, it's a rational number. Yes. Is w less than y? Well, let's see. W is a pretty small number, 0.0013. Is it smaller than this number, 0.000005? No, doesn't look like it. Okay. Y is small, but W is small, but Y is really small. Okay. X plus y is an element of the real numbers. Well, remember, real numbers include all numbers except for the square root of -1. So pretty much take any of these real numbers, add them together, divide them, multiply, do anything of the 4 basic operations, and you're not going to be able to get a non-real number. So yeah, sure, it's a real number. Of course it is. 1 over w is less than x. Okay, we might need the calculator for this. So 1 over 0.0013 is less than x, which is 2600. 26,000, right? Okay, so let's figure out what is 1 is less than, 1 is divided by 0.0013. Okay. 1 divided by 0.0013. Ooh. Let's see. Oh, we forgot. It's still in that weird mode. Well, we don't do that. Mode. Normal. Go back. Okay, now let's go grab this and then we'll hit enter, and we just want to see it as a regular number. 769. Okay. So, is 769 less than 26,000? Of course it is. So yes. Okay. So what do we have no for? We have no for this one. We have no for this one. Which of the 2 following statements about the nature of x, y, w are incorrect? The no's. So that would be 4 and that would be 2.